Okay. Hello everyone. This is group 23, and I'm Shu Wang, and the other two group members Qin Minling and
I'm here.
Qin Zhezhen.
I'm here.
And the next part, we will introduce our code and demonstrate it. And I will first introduce the text one. So in this text, we first, of course, define the car agent, and it has some key attributes like the steps to park, the park step, and the park to check whether the car is already parked in the parking space and the parked at. And we should also define the move and the step, which is to the move. It stands for the car randomly move to the neighboring empty space, and the step is also stands for park. Like if a car reaches empty parking space, is occupies and stays for uh, random steps, like 3 to 5 steps. And after that, it's to define the down, down. Yes, the parking space agent. Its key attributes is occupied and the color, and the occupied is indicates whether the parking space is occupied, and the color is to represent the status of the parking space. The blue is for empty, and the yellow for occupied. And then it's to define our parking lot. And the parking lot is to represent at a 10 to 10 grid with 6 feet fixed parking space at the center. And the specified number of cars are randomly placed in the empty space. And if the car cannot be placed after 100 attempts, and then an arrow is raised to ensure reliability. And about during the each time steps, the steps method is called. Yes, and each car is activate and execute its behavior, move or park. And the next part is yeah, the data collector. The data collector is to calculate the average steps car take to find the parking space. And and the next part is the canvas grid. The canvas grid visualize the simulation. Like the red circle is means the cars that have not parked yet, and the green circle is the car that are currently parked, and the blue rectangle is the empty parking space, and the yellow rectangle is all occupied the parking space. Yeah, I think that's all, and it's time to demonstrate our code, and you can click the start to start this code, and after that you can see some record in the console. Yeah, you can see the car, like how much steps will it remain in the parking lot, and how much steps that the car will leave. Yes, and then we can also like modify the number of cars, or change the number of parking lot. Yes. Yeah, and you can. even see that the car will also park in the parking lot that we added before.
Okay, I'm Jimmy Lee. So now I will introduce the task 2. For task 2, we define the one task class, and then we define the class agent. Task agent is inherent from agent, but it's also is class. And then we define the model, task scheduler models. And let me introduce the task first. We also have the initialization functions to initialize the different properties like the ID, duration, and the resources and the states. And in states, we probably have three states like pending, in progress, and complicated. And we also define a list to store the assigned agent because one task maybe have two agents to handle it. And we also generate a unique color. And first we define the ideal colors. This is green. And then we have the generate unique color for different tasks. And then we have a compact completed to check whether the task is complicated. You can see the duration is less than 0, and we have the decreased duration. In one step, we minor one duration, and we also check whether it's complicated. And then we have assign agent. This is for agents to handle tasks. And in this function, we have states in progress, and we have a release agent. This is function to check whether the task is released by what agent. And the next we have agent. Let me introduce the task agent. We also do same thing as before. We also have the initialization, the capacity, and the current tasks. We use list. This is because one agent can handle more than one tasks. And we also have the assign task to assign a task to agent if capacity allow. You can see because in the instruction, one task maybe handle more than one tasks. And we also have release tasks. If the task is be complicated, we should remove these tasks. And in step, we define to execute the tasks. And one task in one step, we should decrease the duration, which we have right in the task class. And then we have the model. First, we have the number of agents, number of tasks, and the guild for canvas. And we also have the scheduler. We use the simultaneous activation. And we also have the task list, complicated task list. And we also store the step count. First, initialization, we create the tasks. As you can see, each task we first initialize it and then add it to the tasks. Task is the list, so we can directly use the append, and then we print the created tasks to check. And we do same things in the agent. The reason why we should print the tasks because the population of tasks is random. So we should say we should watch the duration and tasks, and the same thing in the agent. And in step, we should advance the model by one step. For each step, we just plus the step count, and then we assign the tasks to the agent. Sorry. And then we should check for the complicated tasks. We use for loop and if functions, and we also log the current state to print which tasks is working on which agent is working on which tasks, and also show the duration. And we also visualization. We use different colors, as you can see, but in the idle little agent is green. And then we define the port and launch it. We can show. As you can see, the counselor is present the tasks. And the agent, you can see the agent 0 is capacity 2, the agent 1 is capacity 1. So let me step by step. The agent 0 is working on task 0, duration 7. And then we plus the accelerate the process. As you can see. Step 1, agent 0 is working on task 0 and task 2. And the reason why the task 0 is from 7 to 5 because the task 0 is handled in two agents, the task agent 0 and agent 1. So for each step, one agent can mirror the duration. And I'm done. Let's welcome to Horizon to introduce the task 3.
Okay, hi, I'm Santa. I will introduce the program that counts words from a text field. So first, we imported essential libraries. Time is used for performance measurement. Multiprocessing allowed us to use multiple CPU cores. RE is for processing text with regular expressions, and the counter is for counting words frequencies. So first, the read fields function reads the content of fields into a string using UTF-8 ensures compatibility with most text fields. And next, the map function processes a chunk of text. The RE found all function extracted words, ensuring case insensitive with point lower. It returns a count object containing word frequencies. And next function is combine results, which merges multiple counter objects into one, summing up words frequencies from different chunks. And next is single thread processing, which uses a single thread to count words. It applies the map function to intern text at once. And the next is parallel marrow duct function, which uses the multiprocessing. It's built text into chunks, processing them in parallel using a pool, and combines the results. And the next is the splitting text function, which splits the text into sentences using regular expressions. It ensures logical separation based on punctuation marks. And the next is the mean performance text. In the mean function, the text is read and split into chunks. First, the single thread processing is performed, and the execution time is recorded. Then, multi-threaded processing is applied, and the time is measured. Finally, the speed up rate is calculated to compared performance, and we can run the program. And we can see first we can see the single throat word count. It shows us the word there is used for the most time. And the next is the same meaning. And we can see the time is 0.09 seconds. And the parallel word count is the same. Yeah, and we can compare the different methods and the time of them. And that's all.
Okay, thank you for your watching. Merry Christmas.